we're going to take this inequality, x is greater than 3, and graph it on a number line. So just to make sure everyone's clear on what this inequality means, right? Whenever you have an inequality, either like this, or with an equal to portion added to it, the thing that is on the open end of it, like this end of it, is always the larger thing, right? So this is telling us that x is larger than 3 because this inequality is opening towards the 3, opening towards the x, I'm sorry. And it's pointing towards the 3, indicating that the 3 is the thing that is smaller. So this is x is greater than 3 is what we're looking at here. So in order to graph this, we only have to really know a couple of things. One is, where does 3 fall on the number line with regards to 0? Well, it's to the right. So we'll put 3 on the number line over here. And you don't need to go 1, 2, 3 if you don't want to. You can, but it's not really necessary. Just make sure that 3 is to the right of 0. Don't put 3 over here, right? That's going to be wrong, because that's where we have negative numbers. And then we have to know to which side are numbers greater than 3. Well, these would be 1 and 2, and this would be 4 and 5. The numbers to the right of 3 are the numbers that are greater than 3. So we'll just draw it looking like this. And you'll note that I've made this an open circle because I'm not including 3. If I had x is less than or equal to, greater than or equal to 3, right, then that would mean that I would want to put a closed circle at 3, indicating that the 3 is a solution option. But here I don't have an or equal to, right? That means that this should just be an open circle. So anytime you see a greater than or a less than sign, those will always be with an open circle. And anytime you see a greater than or equal to or a less than or equal to sign, those will be with a filled in circle on your graph of your number line. So this one is indicating that x is less than or equal to negative 1. Right? That's how we would read this, right? The negative 1 is more than the x because the opening is on the negative 1 side. The point is to the x. So x is less than or equal to negative 1. Right? And the little line underneath is what indicates or equal to. So we need to put negative 1 somewhere to the left of 0. Don't put negative 1 over here. Right? That's wrong. Don't do that. Negative 1 is to the left of 0. And if we want numbers that are less than or equal to negative 1, well, less than on the number line always means to the left. So we're going to put our circle at negative 1. It's going to be filled in because it's or equal to, and we'll point to the left. Those are the numbers less than or equal to negative 1. Even though sometimes people get a little confused, right? This is negative 2 and negative 3, where 2 is more than 1 and 3 is more than 1, right? But negative 2 is less than negative 1. Negative 3 is less than negative 1, right? You can think about it in terms of money. If I owe you $1 or if I owe you $3, right? I have less money if I owe you $3 than if I owe you $1, right? I have less when I owe you 3. So you can think about it that way if that helps. If we want x to be greater than or equal to negative 2, we just need to put negative 2 on our number line somewhere to the left of 0. Because it's an or equal to, we'll put a filled in circle, a closed endpoint there where we include negative 2. And numbers that are greater than negative 2 will be to the right. Every time it's a greater than, x is greater than something, you should be pointing to the right. If it's x is less than, you should be pointing to the left. So this one looks a little bit different, right? We've got the 4 on the left side of the inequality and the x on the other side. So it might be a little bit confusing at first. Right? This is saying 4 is greater than x. But you can also read it backwards. You can read it with x is then because the point is to the x and the opening is to the 4, that means that the x is less than 4. And so when we put our 4 on here and our open circle because it's not an or equal to, we know that we want the numbers that are less than 4. And of course, you can always rewrite this. X is less than 4, right? As long as the point is still at the x and the opening is still at the 4, it's the same inequality. And so now we want the numbers that are less than 4. Well, those are the numbers to the left on the number line. And so our graph should look like that. All right, now we're going to get to the ones that get a little bit more complicated. We've got two different pieces to our inequality, right? We've got -5 is less than x. We've also got x is less than or equal to 3. So I'm going to need both these numbers on here. I'm going to put -5 out here. And I'm going to put 3 over here. Right? -5 should be to the left of 0. 3 should be to the right of 0. And at the -5, I should have an open circle because it's just a less than sign, not or equal to. And at 3, I should have a filled in circle because it's or equal to on that one. It's got the little line underneath. But now we have to determine where these lines off of these endpoints actually go. Well, if I have just this piece that I'm looking at, x is less than or equal to 3. Numbers less than 3 should be going this direction. Okay. If I think about -5 less than x, I could rewrite that as x greater than -5 if I just flip them around and change the inequality so that the opening is still to the x and the point is still to the -5. Now, numbers that are more than -5 should look like this. So it looks like we have the two lines coming towards each other. So the way that we'll actually draw this graph, I'm going to get rid of all this for right now, is since they're coming towards each other, I'll just draw one segment connecting the two of them. And that's all there is to it. Right? This is telling us that we're including all the numbers that are between -5 and 3, just not including -5. Here's another similar one. This time we have -2 and 6. The -2 should have the filled in circle this time because it's got the or equal to on the inequality, and the 6 should have the open circle. And once again, we've got numbers that are less than 6. So that'd be going this direction. But we also have numbers that are more than -2, which would be going this way, right? -2 is less than or equal to x. Just means that x is greater than or equal to -2. Well, if they're coming towards each other, we'll just draw a single line between them. This time we've got two inequalities separated by the word or. We've got x is less than -1 or x is greater than or equal to 4. Right? It's a little bit different from this one. In this one, we were saying both of these things were true. It was kind of like saying x is greater than or equal to -2 and x is less than 6. Both had to be true. That's why we connected them in the middle. Well, here, only one or the other needs to be true. X is either less than -1 or x is greater than or equal to 4. So the less than -1 will get an open circle, and the greater than or equal to 4 will get a closed circle because of the or equal to. And then if we just think about when is x greater than or equal to 4, well, that'd be to the right of 4. And when are we less than something, less than -1? To the left. And we can see why this one is an or, because you can't be both over here less than -1 and over here more than 4 at the same time. Right? You can only do one or the other. Whereas with the previous problem, we could do both things. We could be more than -2 and less than 6, both at the same time, right? Like 1, right, fits that. Right? 1 is more than -2, but it's also less than 6. But there are no numbers that are less than -1 and greater than 4. That's why we have to have the or. All right, so we'll do one more of these, and then we're going to move on and try and write some inequalities from the graph. So here we've got x is less than or equal to 0. Well, I've already got 0 on my number line, so I'll just put a filled in circle there because it's or equal to. And then for x greater than 1, I'll just put an open circle. Whenever you have the or, they're going to have to be going apart from each other because they can't both be true. So we have x is greater than 1. Those are the numbers larger than 1. Or it's less than or equal to 0. So now we're going to switch this around and try and write the inequality once we're given the graph. So here we have a graph that has 4. So we're going to put an x, and we're going to put a 4, and then we're going to have to determine what sign goes in between. Well, the numbers over here are 5, 6, 7. These are the numbers that are greater than 4. So we want the inequality to open up to x, right, indicating that x is greater than 4. And because this is a filled-in circle, right, not an open circle, it could include 4, so we'll say x is greater than or equal to 4. For this one, we know we're going to have an x. We know we're going to have a 2 because that's where our endpoint is at 2. And we're now looking at numbers that are less than 2, right? 0 is included in my solution, and 0 is less than 2. So pointing to the left. So the less than sign means that the point is towards the x. X is less than 2. And it's not an or equal to because it's an open circle. So that's just it. X is less than 2. For this one, our inequality solution includes the number -5. And since we're pointing to the left here, we're pointing to numbers that are less than -5. So we want x to be smaller than -5, less than -5. And because it's a filled-in circle, it will be less than or equal to -5. Here, we've got an x and a 3, and we know that the numbers that we're looking at are numbers that are larger than 3. So we will just say that x is greater than 3. No equal to because it's an open circle. Okay? And remember that for the greater than, the opening is towards the x. So now we'll do a few more that are a little bit more complicated. In this case, we've got numbers that are between -10 and 1. Or sorry, -1. So we're going to start with a -10, and we're going to have a -1 over here. And anytime you have a number line, graph on your number line where it's two different endpoints coming together, I suggest you just always start it like this, with the furthest left number on the left, the furthest right number on the right, and an x in the middle. And then we think about what's happening here to the numbers from -1. From -1, they're going to the left, which would be a less than sign. So I'm going to put a less than between the x and the -1. But I also need numbers to be coming from -10 towards the right, which means I also need to be greater than -10. That means I need to have this inequality, right? X is greater than -10. Well, really what I need is the -10 to be on the left of the x, though, right? I need to kind of swap these around. Well, if I swap them around, I have to change the inequality sign, right? The opening still needs to be with the x. right? So if I swap the numbers around, I have to swap the inequality sign around. Also, I have to have negative 10 is less than x, or x is greater than negative 10. Okay? And so this is my inequality. They're both open circles on the ends, so I don't have an or equal to little line underneath the inequalities. We'll do a similar thing here. So we'll start with a negative 6, an x, and a 7. And we know that we need to be smaller than 7 because we're going to the left of 7. And this time we will include 7, so we'll put the or equal to because of the closed endpoint. At negative 6, we're going to the right. We know that our values of x are greater than negative 6, which means that when we flip them around, the opening still needs to be with the x. So the opening there on our inequality sign is with the x. And when you have these that are both, where we have two endpoints that are coming together, the inequalities should always be pointing in the same direction. If you've got them pointing in opposite directions, you've done it incorrectly, right, when they're coming together. And on the negative 6, we don't have the or equal to, right, because it's an open endpoint. So we'll do a couple now where they're pointing away from each other, and then that'll be it. So here, we need to think about both of these separately because I can't both be over here on this line and over here on this line. That's just impossible. So these are going to have an or in between them, right? I cannot be both of these at once. I can only be one or the other. So for this one, just look at it as if it's a negative 6, right? We're going to the left of negative 6, so we must be less than negative 6. And because it's a filled-in circle, it's or equal to. And over here, we're starting at 4, and we're going to numbers that are larger than 4, and to the right of 4. So it'll be x is greater than or equal to, because of the closed endpoint, 4. So anytime they're going apart from each other, you need to separate the two inequalities with an or. So this will be our last one. We're going to have to separate our inequalities with an or because there's a gap in the middle. We can't be both on this part of the graph and this part of the graph at the same time. So we know that the x values here from the 2 are going to be less than 2 because we're moving to the left of 2. And it's just a less than because it's an open circle. And on the other side, because we're moving to the right here, we know that the numbers are greater than 5, and it will be greater than or equal to because of the closed endpoint.